how do we calculate variance? So if we conceptualize the spread of distribution as the extent to which the values in the distribution differ from the mean and from each other, then the reasonable measure of the spread might be an average deviation or difference of the values from the mean. So as we know, right, so this value is the average and this value is the exact data points. This minus this creates a difference, how much far this value, the data observation is from the mean of the data, and this has been averaged. This is just an built up for variance, and for the variance this is the formula. So the formula of the variance is sigma x minus mean whole square divided by n. So although this might seem reasonable, the last formula, but this expression always be equal to 0 because the negative deviation about the mean will always cancel out the positive deviation. So we need a mechanism where we can drop the negative signs and which is the same as mathematically taking the absolute value, which is called mean deviation. But the concept of absolute doesn't lend itself to the kind of advanced mathematical manipulation necessary for the development of inferential statistical formula. So the average of squared deviation about the mean is called the variation. So we'll see a quick example how the variance will be calculated for the 5 values. We have a set of 5 values 3, 5, 7, 10, 10. So we can see the summation is 35, mean is 35 by 5, 7. How far they are from the mean. So first value is -4, followed by the second -2, and then 0, 3, 3. Next task is to calculate squares. So we have calculated squares for them, so -4. So to take the absolute value so that they don't cancel out each other, the squares coming out as 38. This is our formula. 38 by 5, 7.6 is the variance for this data set. Example 2. 3 people, Dive, Mark and Myrna. So what is the mean, median, mode and range, and what can be said about this data? So mean is 23 for both the data for Mark and Myrna. Median is 22, 27, while the range is 10 and 22. So as we see, the range is pretty high for the second data set, and so would be the variance. So due to outlier, the median is more typical of overall performance. So I think this is a workout calculation. As I said, right, the Mark and Myrna, so Mark has a variance of 12.8, but the Myrna has a variance of 72.4. So conclusion, Mark is the lowest variance, therefore he's more consistent. Second measure is standard deviation. Standard deviation is a measure of variation of scores around the mean. You can think of standard deviation as the average distance to the mean, though it's not numerically accurate. It's conceptually helpful. All ways of saying the same thing. Higher standard deviation increases the higher spread, less consistency, inconsistency, and less clustering. So what the standard deviation is under root of variance that we have seen. So variance formula was squared and then averaged, and this one is squared, averaged, and under rooted. So this is the bell curve that we see for the spread in last few slide. And the empirical formula is what I wanted to explain here, that 68% of the scores fall within one standard deviation of the mean. What does it mean is, let's say this is mean of the data, average, it has to be in the center. And if 68% of the observations falls between mu minus variance and mu plus variance, this is 68%, this area. 95 falls into second standard deviation, mu plus 2 sigma, mu minus 2 sigma, and 99 falls between 3 standard deviations. So all the values, mostly 99.7% of the scores, will fall into mu plus minus 3 sigma. Okay, so the key metrics that we were saying were more from the dispersion, more from the variance, and more from the measures of central tendency. But now we have a key metric which tells about the relationship between two data sets. So we have a covariance here. So as we know, right, the variables may change in relation to each other. So let's say the amount of hard work you put in and the grades, they vary with each other in a positive sense. or the average lifespan of a person and the number of cigarettes he has in a day, they are inversely related to each other. So more cigarettes and less life expectancy. So covariance actually is a parameter that captures that essence of relationship between two variables. So covariance measure how much the movement in one variable predicts the movement in the corresponding variable. For example, smoking and lung capacity. So we would like to investigate the relationship between cigarette smoking and the lung capacity, and the data is a sample data which is coming from the smoking habits and the measured lung capacity. 5 observations same. So a person who is having 0 cigarette can breathe 45 times, and the person who is having 20 cigarettes can breathe 29 times in a minute. So that's the lung capacity and cigarette data. So we'll quickly see how it is relevant from the covariance stand. Inversely proportion. So if we try to plot these points on a metric scale, it is giving me an inverse relationship chart. So as the smoking is increasing, if you smoke for 20 years, then your lung capacity will die down 23. So variables, they vary inversely. That's the observation. And there's another thing which we are introducing here, which is correlation. The covariance and correlation, they are similar things. We'll tell you how they are different, but they both quantify the direction of relationship. So covariance, variables that covary inversely, like smoking and lung, tends to appear on the opposite side of the group means. When smoking is above the group mean, the lung capacity tends to be below its group mean. Average product of deviation measure extends to which variability covary the degree of linkage between them. This is the formula to calculate covariance. So how we are calculating is the average distance of x multiplied by average distance of y. So it's a multiplication of distance of individual observation or the set of observation from their independent means.